All right, math friends, it's Bass Action back in action here. In this video, we are going to look at the formulas for the area. We're going to look at kites, the rhombi, that's the plural of our rhombus. We're going to look at squares, and we're going to look at trapezoids. So we're going to do these three windows. You should already have these other two windows done, the parallelograms and the triangles. I'm going to do some work with patty paper. If you don't have the patty paper at home, no big deal. You can just follow along. You could always grab a piece in the classroom and go back and fill it out later if you find it helpful. So we're going to jump into the kites and the rhombi first. And when I went through the parallelograms and the rectangles in class, I talked about the fact that all of our other area formulas could actually be turned into a rectangle. Okay, so remember, for the parallelogram, what we did for the parallelogram was we took this triangle right here and we moved it over and turned it into a rectangle. That's why their formulas are the same. Remember, for the triangles, what we did is we took one of the triangles and we doubled it and we turned it into a parallelogram. That, of course, is also a rectangle, and that's how we got the 1/2 base times height. So now what we're going to do is we're going to look at the kites and the rhombi. Now the kites and the rhombi are together because their formulas are actually the same formula. Okay, so that might come as a surprise for you, but they are going to turn out to be the same formula. I also mentioned in the parallelograms and the rectangles the fact that when we're looking at an area formula, what we're always looking for are the perpendicular segments. We're always looking for something that's perpendicular because all area formulas come down to the product of two perpendicular objects. So on our rhombi, a couple things we want to put on here. Remember, on a rhombus, the diagonals are going to bisect each other, but they're not going to be congruent to each other. So those two pieces could be congruent. These two pieces are congruent. And then by definition on our rhombus, sorry about that, by the definition of our rhombus, we're going to have all four sides are congruent to each other. Now certainly we have more properties that we could be looking at here. Remember, those are all listed on our blue foldable from the very beginning of the semester. So you could always go back and look at that one. Then, actually, no, I'm sorry, it was our green foldable. Then we want to recognize that a rhombus is also a parallelogram. So we could do, for the area of this rhombus, we could do area is base times height. So let's write ourselves a little note for that. We're going to have a special formula for the rhombus, but we also want to recognize that it would be base times height. If it was base times height, we could pick one of the sides as the base, and then just like our obtuse triangle, our height, we could even draw it outside this triangle. Okay, so it'd be this segment right here. So the product of these two, and remember, anything that you extended to get to that would be ignored. So that's one possibility for the area of our rhombus. Now, if we want to have something specific to the rhombus, we want to remember the fact that the diagonals of the rhombus are perpendicular to each other. And I said we were looking for something that was perpendicular. So let's think about what we could do with these two diagonals, okay, knowing that they're perpendicular. So what I've already done for you on a piece of patty paper is I went ahead and I have traced the original rhombus and I've lightly shaded it in. Then the next thing that I want you to notice that I did is that I took each of these small triangles, these small right triangles that are inside, and I have doubled those, similar to what we did for the area of our triangle. So I doubled this one there, and this one there, and this one there, and this one there. Okay. Now there's other ways that we can do this. This is just the way that I chose to set this one up. Then once we have that, let's think about how we would calculate the area of this rectangle. So if I was going to calculate the area of the rectangle that I've got here right now, what I would do is I would of course say this is the base, and I could say this is my height. So I could say the area of this rectangle would be this base times height. But what I would want to recognize are a couple things. First of all, my base and my height in this rectangle are actually the two diagonals of the original rhombus. So what I really have here is diagonal 1 times diagonal 2. And then, of course, we've doubled everything in order to create the rectangle, and we don't really want the area of the rectangle. We want the area of the rhombus. So we're going to throw in this 1/2. Okay? And if you want, so it doesn't look kind of confusing, we can even put the 1/2 right there to remind ourselves that it's just the rhombus that we're looking for. So the area of a rhombus can be found also by working with the diagonals and doing 1/2 diagonal 1 times diagonal 2. Now, let's go ahead and put that on our blank. So we'll write our 1/2 diagonal 1 diagonal 2. And then what we want to remember is the fact that a kite also has perpendicular diagonals, which means we could do the same process. Now, I didn't draw that one all out for you, but you could go through the exact same process that I did for my rhombus with the kite and see that you get the exact same formula. So I'm going to bold these two diagonals to remind us that those are the ones that we want for the area. Let's put a couple properties in here. Remember, the kite has consecutive congruent sides. They're, of course, going to be distinct congruent sides. So this pair is different than this pair. Remember, we saw that as two isosceles triangles, which means this diagonal, the one connecting the non-vertex angles, is also bisected. So that's our rhombus. The square is going to go really fast. We just need to remember that a square is a parallelogram, so we certainly could do base times height. And then we need to remember that a square is a rhombus, so it also could be 1/2 diagonal 1 times diagonal 2. So options, we could do our base and our height, which would be these two red ones. We could do the two diagonals, for the 1/2 diagonal 1 times diagonal 2. And we can draw in a few of our properties. So we can put our right angles in each of the corners. That helps it stand out why it's base and a height. We can recognize that the diagonals are perpendicular. We can remember that all of these pieces here are congruent to each other because they were congruent and bisected each other. And of course, all the sides in this square are also the same. Lastly, it doesn't hurt to remind yourself that that is a 45-degree angle. Okay, so that's our square. Now let's go ahead and look at our trapezoid. On our trapezoid, you possibly remember this formula from your middle school days. Okay, so from your middle school days, what you had was 1/2. Oops, sorry, started to put that in the wrong spot there. That's going to be for my mid segment. I'm going to come back to that. 1/2 base 1 plus base 2 times the height. And quite possibly back in the day, you just memorized that that was 1/2 base 1 plus base 2 times the height. So let's find those here in our picture. These would be our two bases. Okay, and our two heights are going to be the same because remember, these are parallel. So the distance between those is going to remain consistent, so it doesn't matter where we draw it. And that would be our height. So that's option number 1. Let's talk about why that works. Now, I've done a similar thing with the patty paper that I did with the rhombus. So I've already traced in that trapezoid and lightly shaded it in. Then, very similar to what I did for that rhombus, is I doubled everything. I took this left-hand triangle and I doubled it. I took this right-hand triangle and I doubled it. I took this inner rectangle and I put it on the end. Okay, so now, in essence, I have doubled everything and I turned it into a rectangle. So if we're looking at this base and this height, okay, for the area of a rectangle, what we want to recognize is that this whole piece right here is really base 1, and this piece right here is this other base. So this is base 2. So this side of the rectangle is base 1 plus base 2, and this side of the rectangle is the height. So the area of the trapezoid, we only want half of this whole rectangle that's being shown, because remember we doubled everything. This side of the rectangle is base 1 plus base 2, and this side of the rectangle is the height. That is where that great big formula that you were told back in the day just to memorize came from. So that's that one. Now, the last thing that I want to remind you of are a few other little properties. On this trapezoid right here, this one is an isosceles trapezoid. And we want to remember on the isosceles trapezoid that the diagonals are congruent. And of course the bases are parallel. So we want to remember that. The other thing that we want to remember is this mid-segment that I almost started filling in earlier. So we're going to kind of eyeball a midpoint here and mark that as a midpoint. Now these legs are not congruent, so when I eyeball the midpoint over here, I need to label these pieces as different. And then we're going to draw in that mid-segment. So this is our mid-segment. Doesn't hurt to label that so you remember. So now we've got our mid-segment here. Now, we worked on a formula for the mid-segment. We developed this earlier, and the formula for the mid-segment was 1/2 base 1 plus base 2. Now that should sound familiar to you because this 1/2 base 1 plus base 2 is this part right here of our area formula, which means we can actually just substitute and we can rewrite the area of a trapezoid as the mid-segment times the height. Okay, so those are the formulas that we're going to be working with in class, so be comfortable with those, and then we're just going to jump into some practice.